Have you ever wondered how scientists actually discover things? How do we go from a simple idea to knowledge that the entire world trusts? In this series, we're going to break down research and science in the simplest way possible. And in this first episode, we're going to understand how scientific knowledge is created. And once you understand this process, research starts to make a lot more sense. And honestly, I promise you, it's much simpler than most textbooks make it sound. But before we start, we first need to understand what the word science itself means. It is the process of producing knowledge and the knowledge itself. And it's important to understand that science is not just one single field. There are actually different types of science. And here we're going to talk about the two domains of science. Alright, so we have natural sciences and social sciences. Natural sciences focus on the physical world. They study how nature works. Feels like physics, chemistry, biology, and all belong here. Basically anything involving atoms, planets, or living organisms. And then we have social sciences, which are very different from natural sciences. Instead of studying nature, they study human behavior in society. For example, sociology studies how people interact. Economics studies how resources and money move in a society, which is sometimes harder to predict than physics because, humans are just complicated. And although these two fields are very different from each other, they still share a common denominator, which is the structured way of discovering knowledge. And this structured process is called scientific method. But what even is this, and why do we even need it? Scientific method is basically a set of steps scientists use to test their ideas, so they make sure that the conclusions they want to share with the world are actually true and reliable. Because without these steps, science would just basically be opinions. Let's take a look at this process step by step. It often starts with an assumption, which is basically an initial observation or maybe even a thought. Then scientists form a hypothesis from that assumption. What is a hypothesis, you may ask? A hypothesis is a testable prediction. And if we repeat studies that support that hypothesis, it can develop into a theory. And a theory explains why something happens based on strong evidences. And sometimes if something is constantly proven and predictable, it can even form a scientific law. When you study about research, you will come across this word several times. So it's important to know what it actually means. A variable is simply something that can change. We have two types, quantitative and qualitative. To put it simply together, anything that can be measured with numbers, anything you can put into a calculator is a quantitative variable. On the other hand, a qualitative variable is anything else that you cannot measure with numbers. For example, eye color, gender, or types of food. Instead, they're put into categories. Next, we're going to talk about the types of quantitative variables. They can either be continuous, which means that they can take any value, for example, the length of your tooth, or they can be discrete, meaning that they can only take whole numbers. For example, how many of your teeth are missing. We also have different types in qualitative variables. We have nominal and ordinal, which are exactly the opposite of each other. Nominal variables are unordered categories, such as gender, and ordinal are ordered categories, as the name suggests, such as pain levels, such as mild, moderate, and severe. Or things like movie ratings, from terrible to amazing. Now you learned how to define your variable, and now you can start with the actual research process. Most research follows a structured process. First, researchers identify a problem or a research question. Then they develop a hypothesis. After that comes data collection. Researchers gather information through experiments, surveys, or even observations. Next, the collected data is analyzed to find patterns and relationships, and this part can sometimes take a really long time. And then finally, researchers report their findings so other scientists can review and learn from them. And let's not forget about statistics. They also play a big role in research. The process usually involves 4 stages. First, data collection. Second, organization of the data. Third, presentation, which often requires charts and graphs. And finally, analysis, where researchers interpret the results. But the big question is, how do we even get these data? There are 2 ways. We have primary data and secondary data. And primary data is when you do the work, you collect the data yourself. And secondary data is when someone else did the work and collected the data, and you're just using someone else's work. Okay, so till now everything seemed to be easy and understandable, but what's the point of this? Why do we even need to know all these processes? To understand the big picture, imagine this. In healthcare, this entire system we have been talking about is the engine of what we call evidence-based medicine. It's a huge shift from the things how we've always done it to towards things and making decisions based on the absolute best scientific evidence available. At the end of the day, it's about using data to save lives. To really get this, we need to understand the pyramid of knowledge. Right at the very bottom, we have data. This is just raw, unorganized fact. Imagine a list of patient ages at a doctor's office. By itself, that list just means nothing. It's literally just a bunch of numbers. But then, when you take that raw data and process it, it becomes information. All of a sudden, it starts answering questions like who, what, and where. That boring list of ages now has become a helpful chart of the age breakdown of the patients who came in last week. See, now it has some context. And at the very top of that pyramid is knowledge. This is the step that only we humans can do it. It's where we combine that information with our own experience and our own insights and values. It's not just seeing the age chart. It's understanding why that age group is coming more often and what that means for how the clinic should operate. Data can live in the computer, but knowledge lives in a person's mind. And to answer the question asked earlier, this is the entire point: to make decisions without error or with minimal error. And that brings us to the end of this episode. Thank you for your attention and wish you guys all the best for your exams.